Okay, gang, welcome back. Happy Wednesday. Today is our fourth class of the semester. We're going to talk about these topics here: dimensional analysis, ratio, and proportion. So a couple things a little bit unusual about today. First of all, the demo is going to be longer than normal. The demo, remember, is the part where I just kind of lead the way, and that's going to take us longer than it normally does. The activities are also long, and that's the part where you work in your neighbors, and I don't think we're going to get it all done in the hour and 10 minutes that we have. So what's going to happen is we're going to work all the way until 9:50, and then we'll probably steal like the first 10 minutes of our next class wrapping up what we didn't quite get to today, okay? And I think that'll be okay. We'll have time to do that and still accomplish slope next time. Also, you can see that instead of having a section number here, which is from your textbook, it says supplement. Today's material is not in your textbook, so that means all of the resources that you're going to use are going to be in the packet. And also, in terms of the homework, you don't need to take this out, but I'll just show it to you. Here for option, or for day number 4, can I? Oh. For day number 4, you can see instead of having some problems in your textbook, it says see supplemental problems for homework 4 on the next pages. So if you just flip to the back of this very first page, it says right there, here are the problems you're going to do for class number 4. That's today. All right, and so they're all here. Lots of word problems. Goes to the very next page, and then an answer key, but don't look there until you've given the problems a shot on your own. Okay, so tonight's homework not at all in the textbook. It's all here in the homework packet. You just have to turn the page. All right, one other thing to talk about before we jump in with the new stuff. I would like you to take your syllabus out for a second. And the syllabus at the end, the front of the syllabus looks like this. Just says Math 096 at the top, Intermediate Algebra. And at the end of this document were 2 different calendars. Now, some of you have already ripped off the Tuesday, Thursday page. If you haven't, then I'd encourage you to do that. So I don't want us to look at the Tuesday, Thursday page, but I want us to look at the Monday, Wednesday, Friday page. So that might be the last page already for you if you've already ripped it off. But anyway, make sure you're looking at the Monday, Wednesday, Friday thing. And you need to fix the mistake that I made. So all the way at the bottom, it says final exam December 20 and also December 21. Everybody see that? Okay, December 21 is not correct. Cross that off. Replace it with what's written over here on the whiteboard. December 19th, 10:30 until 12:30. Cross off the 21st, and instead put the 19th, 10:30 until 12:30. (10:30 to 12:30). All right, so the reason there are 2 final exam times listed, so December 20th and then the new December 19th, is that I teach 2 sections of this course. Our official time to take the final exam is correct as written on your syllabus. It's December 20th at 8 in the morning, but it doesn't make any difference to me if you come to this class or if you come to my other 096 class to take that final exam. So I'm giving you 2 options. It's just that the second option was not correct. It should be December 19th. Any questions on that? Okay, so let us jump in again on page 26 of the big packet. So here we go. In this lesson, we learn how to use dimensional analysis, whatever that is, to do unit conversions and to help us set up proportions to solve application problems. So here's our first example. Gas costs $3.57 per gallon. You fill your car with 12 gallons of gas, and then you buy some items for $15.35 at the counter. And so what I want to know is how much money do we spend altogether? $3.57 per gallon, 12 gallons, and then another $15 and change of additional items. Would you guys agree that this right here is the calculation we want to do to figure out how much money we spend altogether? $3.57 per gallon times the 12 gallons, right? And then just add the other $15 and change. Okay, so the total is $58.19. That's not the important part. What I want to harp on are the units. None of the numbers in that highlighted thing have units. Let's fill them in this blank line right here. It's the same calculation, just with some space for the units. Let's start with the $15.35. What are the units for that? That's dollars. Go ahead and put that in there. How about the 12? That's gallons. And on the right-hand side, 58.19, also dollars. Okay, now let's focus on the blank here in the front. 3.57. What are the units for that number? It's dollars per gallon. It is not $3.57. Gas does not cost $3.57. That doesn't make any sense for me to say that without telling you how much gas you are purchasing. So it is $3.57 per gallon. So it's dollars per gallon. And so if I remove the numbers and I just look at the units, which are now written up there in blue, it's typed down here. Forget about the crossing off that's happened, but we had dollars per gallon times gallons plus some dollars equals some dollars. And now we can cancel those gallons, right? One on top, one on the bottom, and we get dollars plus dollars equals dollars. And that makes a lot of sense. In order for you to have an equation with units in it, the units on the left side of the equation have to match perfectly the units on the right side of the equation. Yeah? Like I could say 3 equals 2 plus 1, and you could say sure. But if I said 3 apples equals 2 oranges plus 1 orange, you would say, right? Units have to agree in any equation. That's going to help us. So we're going to see how that helps us on a problem on the next page. But first, we'll shift gears just a little bit and talk about ratios and then proportions. So first, some definitions. A ratio compares two numerical quantities through the operation of division. So you see the word ratio, that just means to divide. A ratio is often written as a quotient, which is a fancy word for just saying a fraction, such as A over B. So you could have like 3/7. That is a ratio, just division of two numbers. But there are a couple of ways to write this 3/7. You could also write 3 to 7, like with the word 2 in between. 3 to 7. That means exactly the same thing. 3/7, 3/7. And then you could also write 3:7, and it's still read 3 to 7, even though it's a colon. All right. Next vocabulary word, that was ratio. Here's proportion. A proportion is just an equation of two ratios. So for example, this one right here, it is one ratio, one fraction equal to another. Anytime you have two fractions equaling each other, that is called a proportion. And we're going to have a technique right here to solve a proportion. So let's solve this equation right here together. Now, some of you might have done something called cross multiply in a previous math class. Raise your hand if that sounds familiar. Cross multiply. We'll come back to cross multiply. I'm going to give you a different technique. Cross multiply works. It's totally fine. I'm going to give you another technique instead, and then you can choose whether you like my technique or cross multiply. It's up to you. So here's my technique. We are going to multiply both sides of this equation by both denominators. It's written up here in bold. Multiply both sides by both denominators. So on the left-hand side, I'm going to multiply by 7 because I see a denominator of 7, but I'm also going to multiply by the other denominator. Go ahead and put that in up there. 7 times 5 times. But I cannot go around multiplying the left side of my equation by 35 without also multiplying the right side by 35. I'm saying 35, but I still want you to write it as times 7 times 5, both sides. Okay, and then the point of multiplying both sides by both denominators is that lots of stuff cancels. So on the left-hand side, what can I cancel from top and bottom? There's a 7, right? There's a 7 on the top, there's a 7 on the bottom, and they disappear. What can I cancel on the right side? Is 5, so get rid of those. And now we're going to write down the remaining equation. I see an orange 5, I see it times, I see an x minus 1. I see an equals 3 times 7, right? Okay, I have made a fatal mistake in this problem, and if I finish solving it here, I'm going to get the wrong answer. Anybody see something that I should have brought in? I should have brought in parentheses. Around what? X minus 1. Got to be in parentheses. Because x minus 1 was an entire numerator. And every fraction line gives you implied parentheses on the top and implied parentheses on the bottom. And that x minus 1 was like in a bag, and that bag is getting multiplied by 5. But the way I had written it before, it looked like the only thing getting multiplied by 5 was the x. Okay. Technically, I could have put the 3 in the parentheses as well, because it is an entire numerator. It's not crucial on that side because 3 is just a single term, no distributing there, but we need it on the other side. Okay, so finishing this problem is not really interesting, so I'm actually not even going to do it, but you distribute the 5. That's written right down here. And then add the 5, right? Add 5 to both sides, and then divide by 5, and you're all done. So 26/5 is the answer. Okay, so our technique, multiply both sides by both denominators. Other technique from a previous math class is cross multiply. So you can write this if you want, but you don't need to. I'm going to copy the original equation here. X minus 1 over 7 equals 3 over 5. Somebody tell me what the next step is if we do this thing called cross multiply. What do we do? It's okay with me if nobody knows cross multiply, because I don't want you to use it anyway, but if somebody knows it, we can talk about it. Okay, 7 goes with the 3. Do we add them? Multiply them. And also, yeah, so there is a division if you want to be really fancy. We're going to do it in 2 steps instead of the 1. Yeah, so we're going to multiply the 2 diagonals together. So let's do that here. So on the one diagonal is x minus 1 times 5. So I'll put that here. And then on the other diagonal is 7 times 3. I'll put that over here. What symbol goes in between? Equals. It used to be an equation, it's still an equation. Fantastic. So that's cross multiply. The product of the 2 diagonals are equal to each other. What's the relationship between that cross multiply? Come on in. That result and the one that we had before? Exactly the same. And in fact, cross multiply was quicker than what we did because cross multiply avoids all this, multiply both sides by both denominators and then cancel and then rewrite. So why would I tell you to do this thing that's less efficient, multiply both sides by both denominators, when you could just do cross multiply and save yourself, I don't know, 20, 30 seconds? Because cross multiply seems like a miracle to me anyway. It's like, what's going on? It's just this like magic, you know, somebody said, hey, multiply the diagonals and slap an equal sign in between them. So I'm not really a fan of that kind of stuff in my math classes. I want my students to understand what's happening. Multiplying by 7 and 5 might not, it might not have been clear why we were doing that, but now it should be. And certainly it is legal to multiply both sides by 7 and 5, same thing. And the other reason I'm not a huge fan of cross multiply is that suppose that I gave you a very similar looking problem to this original thing, but it was this, x minus 1 over 7 and then 3 over 5. What's the difference between that problem and the original problem? It's not equals. What is it now? Now it's multiplication, right? Looks similar, totally different thing I'm asking you to do. How do you multiply 2 fractions? Straight across. But some people are going to look at that, and if they've been thinking cross multiply, they might start to think, oh, I'm supposed to do something with these diagonals. It is straight across. And so I'm just reluctant to potentially like mess up the fact that you know how to multiply by giving you this really strange technique that happens to work for solving equations of fractions. Okay? Whichever one you choose is totally fine. Okay, so let's move on to the next page. Okay, here we go. We're on page 27 now. Okay, next word problem. The ratio of male students to female students at GCC is 2 to 3. I'm reading the word 2 from that colon in the middle of those numbers. If there are 2,000 students at GCC, set up and solve a proportion to find out how many are female. 2,000 students altogether. We want to know how many of those 2,000 are female. Okay, so first, a carefully defined variable. It's actually written, but don't read it just yet. if you look at the problem carefully, you'll find what I think you should let X represent. I'm asking you one specific question, and whatever you define X to be, it would be lovely if that would answer my question. So you should let X equal how many are female. We'll say that in a slightly less awkward way. We want X to equal the number of females. Yeah? So that's written right down there. And make sure that you do not do something like this, let X equal females. That is a good way to lose a point on my test or quiz. X equals females is not a good definition. If you say let X equal females, I'm going to ask you, are you talking about like X is like the GPA of the females? Is X the height of the females? Is X like the favorite singer of the females? What about the females are we interested in counting or measuring? And the only characteristic of the females that we care about for this problem is how many there are. And so all you have to do is include the word number in your definition. Not just females, but number of females. Okay, so we are going to carefully set up a proportion in order to solve this problem. So here we go. I'm starting this problem with two blank fractions equaling each other. Just putting that down as like an empty skeleton is an important part of the process. Now, a lot of folks are going to want to start putting numbers, 2's and 3's and x's inside of into these fractions here. I encourage you strongly to not start there. Let's start with some units. On the left-hand side, I've got male students and female students. I'm going to put female students in the numerator and male students in the denominator. Go ahead and copy that for me in that blank space. And I am going to say that we could just as well have solved this problem by flipping those units over. Could be males in the numerator, females in the denominator. It's all good. Doesn't matter what choice you make right there. But as soon as you make that choice, you have no more freedom on the right-hand side. What units do I have to put on the right-hand side? What am I putting here? What words? Which one's on top? Female in the numerator, male in the denominator. I have to copy that. We saw with the gasoline example, units on the one side have to equal the units on the other side. So we had choices on the left-hand side for that fraction. Could have flipped it over, no problem. But as soon as you make a choice, you are forced to make exactly the same choice on the other side of the equation. Okay, it takes like 10 seconds to write those units in, but I promise you it is worth your time. Now we can start filling in the numbers. It says the ratio of males to females is 2 to 3. The left-hand fraction, it's either going to be a 2 over 3 or a 3 over 2. Just have to carefully put it in and make sure you are aware of the order. So the first word here is male, second word here is female. The first number, oh, this is like one of my favorite things about the smartboard, is that like some programmer, you see what happened up here with the yellow highlighter and the blue highlighter? What happened in the overlap? It's green. I didn't put green there. Some programmer was like, hey, this is going to be cool. If they do yellow on top of blue, we're going to turn it green. It's the little things in life. All right, which one of those numbers represents the males, 2 or 3? 2, it's the first one, it's the order. So I'll highlight that in green. And then the female was second, the 3 is second, they go together. So I think it should be pretty clear which one goes up here for female. 3, just put it in. Okay, 3 up there, and therefore male is 2, 3 to 2. All right, if we had made the other choice, male over female, we'd just flip those numbers over. It doesn't make any difference, but just be consistent. Write the words and then fill in the blanks. Okay, next one. I got to get my X in here someplace, right? So what do you think? X is the number of female. Where are we putting it? Up on top, right there. It's so easy. If you just guess, like if you don't know exactly which one is female, which one is male, half the time you're going to put that X in the wrong spot. Like it's totally okay to put the 3 over 2 or the 2 over 3. But once you've made that choice, if you are just guessing where the X goes on the other side, you're going to get it wrong half the time. But if you put the numbers, sorry, put the words in, the units in, I think you're going to get it right every time. Okay, last one. I've got one more blank. It is supposed to represent the number of male students. What's the other piece of info we haven't used yet? 2,000. Is 2,000 the number of male students? No, we don't get to just put 2,000 here. 2,000 represents the total number of students. Okay, so we got just one last little bit of calculation to do. So some of you might already know what's supposed to go here. It's going to have a 2,000. It's also going to have an X. But if it is not clear to you what's supposed to go there, we just make a number up. Let X equal, I don't know, 100. And again, X is females, right? Just making up a number. Suppose that X is 100 females. If there are 2,000 students altogether at GCC and 100 of them are females, what number would I put down here for males? 1,900, yeah? And how do we calculate that 1,900? We just do the 2,000, subtract off the 100 to get me 1,900 male students, right? It's easy. But it wasn't 100, it was X. So instead of 2,000 minus 100, it is 2,000 minus X. That's what we put right down there. And that's our proportion. And I will say that sometimes we get like a subtraction down here, like a 2,000 minus X. Other times it's going to be 2,000 plus X. Other times it's just going to be X. You can't, like, don't try to memorize, oh, it's always the other number minus X. It isn't. You have to read the problem and very carefully analyze and figure out what would be appropriate to put down there, okay? All right, you are going to solve that proportion in the activity. So it's not quite done, but you'll finish this as the first problem in the group activity. We've got one more example we're going to do together. It's on the next page. And this one right here, we are going to call the baby example. It has to do with babies. And in your homework for tonight, it is going to say, do this problem using the technique in the baby example. This is the technique we were talking about. It's bolded, it is underlined. This is the baby example. You will see it referenced in the homework. Okay, here we go. In the US, a baby is born every 3.2 seconds. That is not true, I just made that up. But suppose it is true. We are going to figure out how many babies are born in the US each decade. That is the question we're after. How many babies each decade? One baby every 3.2 seconds. Translate that up to how many babies per decade. So here we go. I've written one baby every 3.2 seconds as a ratio. There it is, one baby per 3.2 seconds. I'm going to multiply this by a certain thing. Let me ask you this. Suppose that I have 3 over 7, and I want to compare that to 18 over 42. Can you guys tell me how these two fractions, like the values of those two fractions, how did they compare to each other? So I multiplied top and bottom of the first fraction by 6, and that gives you the second fraction. So what does that mean about the values of these two fractions? They're equal, right? It's exactly the same fraction. In fact, if I gave you 18 over 42 and I said reduce, you would land on 3/7. And so what that means is that if you multiply here, top and bottom by the same thing, you have not changed the value of the fraction. Said another way, if you multiply something by 1, you have not changed it. Agree? 1 is the only number I can multiply something by without changing it. All right, so what we are going to do is multiply this 1 over 3.2 by the number 1. But we're going to multiply by the number 1 in a very clever way. So here we go. Give me a blank fraction line right there. I do not like the fact that this one has the word seconds in the bottom. I would much prefer it have decades. So if I don't like the word seconds there and I want to do something to cancel it, would you prefer putting seconds on the top or the bottom of this blank fraction? Top. I'll put seconds right there. Okay, we are trying to get from seconds eventually to decade. There's a lot of units of time in between seconds and decades. We just have to go to the next one. After seconds, what's the next bigger unit of time? Minutes. So go ahead and put minutes right there. Now we're going to put some numbers in. We are going to put a 1 next to the thing that is bigger. Which one's bigger, minute or second? Minute. Put a 1 right there. It'll be clear why we're putting a 1 there in just a moment. Now, how many seconds are in 1 minute? 60. Put a 60 right there. Would you agree top and bottom of this fraction are equal to each other? Yes. If top and bottom of a fraction are equal to each other, like 6 and 6, what is the value of that fraction? It is 1, right? 60 seconds over 1 minute is just a funny way to write the number 1 because top and bottom are equal. And multiplying by 1 is the only thing I'm allowed to do without changing the original fraction. So that is the only thing we're going to multiply by. And then we get to cancel seconds and seconds. And we currently have babies on top, minutes on the bottom. Still pretty far to get to decades, but we are heading in the right direction. Let's do this again. Times blank fraction. I don't like minutes. Where would you put minutes in the next fraction to cancel? Top, let's put minutes there. Next up, next unit of time, hours. Okay, now I said let's put a 1 next to the bigger thing. Let's think for a second about why I said for us to do that. You are perfectly welcome to put a 1 next to the smaller thing, 1 minute. But if you're going to do that, then what you have to do is figure out how many hours there are in 1 minute. Do you guys happen to know how many hours is the same as 1 minute? Well, it's a really tiny number of hours, right? Like it's a small fraction of an hour. In fact, it's 1/60th of an hour. So you are welcome to put 1 minute on top and say, hey, that's just 1/60th of an hour. But then you're introducing these fractions. You don't need to. Whereas if you go the other direction and you put a 1 on the bigger thing, then you're going to just put a whole number on top. What number am I putting on top? 60. 60 minutes is equal to 1 hour. So that's a fraction whose value is 1. And then we get to cancel. Okay, let's do the rest of these a little bit quicker. Again, where am I putting hours now to cancel? Top, hours there. Next unit of time, day. Put a 1 on the day. It's the bigger one. And then 24 on the hours. And then we cancel the hours. Good there. Okay, next fraction. Where do I put days? Top. Okay, now there are a few natural choices for what you put on the bottom. Give me another unit of time bigger than days. Years is fine. Another one. Months is fine. One more. Weeks is fine. You got 3 natural places to go right here. Only one of them is good. Only years is good. Because if you go days and weeks, no problem, 7 days in every single week, right? But then you have to get from weeks to years. How many weeks in a year? 52, right? We've all memorized 52 weeks in a year. How many days in a year? 365. We'll ignore leap years for this problem. Has anybody ever checked that 52 weeks matches 365 days? Have you ever checked? What calculation should I do? Yeah, another calculation involving multiplication. 52 times what? Times 7? Yes? That would tell us how many days in 52 weeks. 7 times 2, 14, carry the 1. 7 times 5 is 35, plus the 1 is 36. Are there 52 weeks in a year? There are not. There are not 52 weeks in a year. There are 52 weeks plus a day. So that's a problem. If I go days to weeks, then all of a sudden I've got to bring the number 52 in, and that's not right. So days to weeks is bad. Days to months is probably even worse. How many days in a month? Yeah, it changes, right? 28, 30, 31, 29 if we get leap years in there. Okay, so days to years is the only natural place to go. So we'll put years right there. Again, we'll put a 1 on the bigger thing, that's years. And then again, ignoring leap years, how many days? 365, put that up top. And then we are almost there, last fraction. Oh, and then we can cancel the days. Okay, last fraction. I don't like years here. What do I put? Where do I put it? Up there. And then the goal for this whole problem has been what unit of time? Decades. So we are finally there. Where am I putting my 1? On the bottom, decade. How many years in a decade? 10, no problem. And then we cross off years. And almost all of these units have disappeared. What's the only unit left on top? It's baby. And on the bottom, decade. Babies per decade is our current unit, and that's what we were after. So the last piece of this puzzle is to actually get a number. So here's how we get the number. You don't need to do this on your calculator right now. But all we're going to do, we know how to multiply fractions. Straight across on top, straight across on the bottom. I'm going to do it in two separate calculations. Okay, so it's a 1 times, I'll put it even though it's kind of silly to do the 1 times, and then there's a 60 that's partially cut off by my calculator, and then times another 60 over there, times 24 times 365 times 10. I've got all that. Okay, so that is my numerator. Can you write that down real quick? Got some blank space on the, like below this problem. And then the denominator of this thing is actually quite a bit easier because it's a whole slew of ones on the bottom. What's the only number on the bottom? Not 1. 3.2. So 3.2 times all of those ones is still 3.2. So the bottom is going to be 3.2. And so I'm just going to take my answer and divide it by 3.2. And I get that number there. Write that one down for me as well. Okay, so that's going to disappear in just a second. I'm going to need folks to read this stuff to me. So I got 3153, and then I think there was a 6, and then how many zeros? 1, 2, 3, 4. And then that got divided by 3.2. And what was the final answer? Say it, 9 million. So 3 zeros at the end? 1, 2, 3. 4 zeros at the end. Okay. No worries. Okay, so 98,555,000, and then getting the units in there, babies per decade. All right, and that kind of technique that we just did in this baby example is called dimensional analysis. You don't really need to know the phrase, but anyway, we analyzed all of the units, and the word dimension is kind of like unit, so dimensional analysis, analyze the units. So we had two big techniques for today. One of them involved setting up a proportion. That was an equation with two fractions. The other one is this thing where you just multiply, multiply, multiply. No variables, no equations, just multiply by ones, all right? It's really easy to confuse the one technique with the other based on like all the problems are going to kind of sound alike in this section. So just be careful when you read the directions. If it says proportion, like the first few, you are introducing an x and you are writing an equation with fractions. But if it says dimensional analysis or the baby example, no x's, no equations, just this multiply by lots of stuff and chase the units. All right? Okay, so you're going to jump into the activity. It starts 1 or 2 pages away. I don't think you're going to finish the activity, but still you're going to work real hard all the way until 9:50, and then we'll steal some time next class to finish the activity.